New day, new outfit, it would appear. Yay! That means we're going to do a couple videos here left in chapter 3. Really 2 sections I hope to do in this outfit. Section 4 of chapter 3 and then section 5 of chapter 3. This one, in this chapter we're going to be dealing with, or in this section of chapter 3, we're going to be dealing with linear equalities in 2 variables. So we've graphed lines before, x plus y equals 3. We've graphed equations with 2 variables. Now we're just going to look at linear inequalities with 2 variables. Bit of a change in weather today. Sidetracked, I don't know, I looked outside and got sidetracked, I guess. It kind of snowed last night. Ooh, I'm tapping my finger. I noticed yesterday as I was watching kind of some of the videos over, I do that a lot. And it's kind of annoying because you can hear it through the speaker. So sorry about that, but I'm not going to redo the videos. You can deal with it. Anyway, now that we're a minute in and I've wasted a minute of your lives, let's see if I can waste about, I don't know, 10, 15 more minutes, maybe 15, probably somewhere in there. There's some eraser shavings on my desk. Anyway, so we'll get going. So we're going to graph linear equations with 2 variables, graph intersections of 2 linear inequalities, graph the union of 2 linear inequalities. We're not going to use graphing calculators to do this. So the first thing we're going to do is we're going to talk about how do we go about graphing linear inequalities with 2 variables. So just kind of a reminder, 2 different types of inequalities with 2 variables. We have ax plus by is less than c, or ax plus by is greater than c. A, b, and c are real numbers. A and B can't both be 0. And this is a linear inequality. I mean, it's going to form a line, but now our solutions aren't necessarily just going to be on the line. They're going to be in a kind of a shaded region. So if you remember from Algebra 2, these are where we graph. We put little dotted lines or solid lines, and we graph either above or below the line. So here's an example of a linear equation. This is the equation. Our line is anyway x plus y equals 5. That's that line. All the pink area down there is the values that are less than. X plus y is less than 5, and all the areas in the blue are the areas that are greater than 5. So this is kind of what we're going to be looking at today. We're going to kind of use those symbols to replace kind of the shaded area. Again, it's not the line anymore. Your solutions are going to become in those shaded areas of this. So that's kind of just an explanation. So kind of the process, the step-by-step process through this. Step 1, you're going to draw a graph. Right? You're just going to change the inequality into an equation and graph it, either by finding the intercepts, slope-intercept form, whatever it might be. Now, that line is going to be one of 2 things. It's either going to be solid or it's solid, or it's going to be dashed. It's going to be solid if you're using the greater than or equal to or the less than or equal to symbol. Okay, then you're going to have a solid line. You're going to have a dashed line if it's just greater than or less than. Then you're going to have kind of that dashed line going on. The next thing you're going to do is you can pick a test point. One way to do this is to pick a test point. You pick a point that's not on the line and you put it into the inequality. If that becomes true, if that point that you come in there, you end up with a true statement, then the region that that point is in, whether it's above the line or below the line, you shade that region if it's true. If it's false, you shade the other region. Okay? And then that kind of leads to step 3, you shade after you kind of do that test point. Okay, so to keep, again, in mind, it is specific as to if it's solid or if it's dashed. So please make sure you're paying attention to what the inequality symbol is. Remember, if it's greater than or equal to or less than or equal to, it's solid. If it's greater than or less than, then it's just dashed. Big error comes in this one if you miss this one. Okay, so let's do an example. So we're going to graph x plus 4 is less than or equal to 4. So the first thing's going through my mind is less than or equal to, so I know I've got to have a solid line. So I'm going to go ahead and graph this. We can graph this in one of 2 ways. You can write it as the equation x plus y equals 4. You can solve for y. So we get y equals negative x
My apologies.
plus 4.
I couldn't hear what you said.
I didn't say anything to you, Siri. So this is one way that you can do it. And this is what we did, I think, in the last unit when we graphed linear equations. We solved for y quite a bit. So we've got the slope and we've got the y-intercept. And to me, this is it's one way to do it. Is it the easiest way to do it? It depends on what you want to do, I guess. But now you're going to go ahead and graph that. So we have a y-intercept. My b value is equal to 4. So I'm going to go up 4. It's a nice straight line, by the way. So I go up 4, I put a dot. And now my slope for this is equal to negative 1. So since my slope for this is negative 1, that means I go down 1 and over 1. I don't know if that's backwards on the screen or not. I don't know. But you go down 1 to the right 1, and you put another dot. So now we get 2 points. That forms a line, which is what we want to do. It's greater than or equal to, so it's going to be solid. So it's going to be a solid line. Okay, now we're going to go back into our inequality. So this is our inequality over here. So step 2, so we've got a graph. So step 2 is to find a test point. So we're going to pick any point that's not on the graph. If 0, 0 is not on your line, use 0, 0 every time. So we're going to do this test point. And we're going to pick 0, 0 because it's not on the line. So that tells me that 0 plus 0 is less than or equal to 4. So is 0 less than or equal to 4? Oh, I think so. So this is true. So since this is a true statement, and again, where did I get this 0 plus 0? It's right there. I just replaced my x value and my y value with 0. Since it's true, then, that means I'm going to shade in this region. So all of my solutions are going to be down in my shaded region down here. And that's essentially how you graph. Now, this is one way to do it. And this is how, I like to solve for y and find the slope and find the y-intercept. You don't necessarily have to do that. My guess is they do it a different way. They use the intercepts. Remember, you can always find the intercepts. Set x equal to 0, solve for y. So that's what they did. They set y equal to 0 and solved for x. And then they set x equal to 0 and solved for y. There's what the graph, and then you just graph those 2 points. It's a solid line. They tested 0, 0. They found out that it was true. Since 0, 0 is true, you shaded in that region. So either way, it doesn't matter. You can find the intercepts, or you can do slope-intercept form, whichever way you are more comfortable with it. Okay? And this is kind of what I said. And here's just a general rule. If you don't want to use test points, you don't always have to use test points, but you have to be careful with this. In order to not use test points, it has to be in slope-intercept form. If you do the way they did it, you have to use a test point. If you did the way I did it, you don't necessarily have to use that test point. So if the equation is written in the form y is greater than mx plus b, or y is less than mx plus b, the inequality symbol indicates which half of the plane that you're going to shade. So if it's greater than, you're going to shade above the boundary line. If it's less than, you're going to shade below the boundary line. Now again, this only works if it's in the form y equals mx plus b. If it's not in that form, or if you're going to use the intercepts, you have to use the test points. Otherwise, it kind of messes this whole thing. Okay? Again, they say it again. It only works if the inequality is solved for y. Okay? So example 2. And whatever way you want to do it. So we've got 3x plus 4y is less than 12. So I'm going to go ahead and I'm going to solve for y because that's how I like to do it. So write it as an equation. I'm going to subtract 3x. Oops, I said an equation and I wrote it as an inequality, of course. Pretend that's an equal sign. So that's negative 3x plus 12. You're going to divide by 4, and you make sure you divide everything by 4. So y equals negative 3/4 x plus 3. So my y-intercept is 3. I put a dot at 3. My slope is negative 3/4. That tells me I go down 3 over 4. I look at the symbol. It's less than, so it's dashed. And now because I wrote it in slope-intercept form, I can use their little rule. It's less than, so since it's less than, it means that I shade below. And again, if you use the intercepts, perfectly fine. Just make sure you use the test point and a test point that's not on that line. Right. See what they do. Yeah, they did it this way this time. Okay, there's what it is. Imagine that's what we got. Again, you can always test a 0, 0 to see if it works. Okay, so there's one, if there's just one inequality. Now we're going to go ahead and graph it if it's two inequalities. Really no different, but you're going to have two inequalities on the same graph. Okay, so you're going to kind of have this double shaded region. So we're going to go ahead and graph y, x minus y is less than or equal to 4, and x is greater than or equal to negative 2. So we've got two graphs that we're going to do. So we're going to start out by just picking one of them. So we're going to write it as an equation. Isn't going to be much fun, but let's solve for x. So solve for y equals negative x plus 4, but it says negative y. So since it's negative y, I have to switch all of the symbols. So this is going to be x minus 4. So I'm going to go ahead and graph that. My y-intercept is negative 4. My slope is 1. So my y-intercept, remember, is this negative 4 right here. My slope is 1, so up 1 over 1. So if I write this as an inequality now, notice what I did when I did this inequality. Okay, and this is kind of where you got to be a little bit careful, because if I would have left this written as an inequality, I would have had x minus y is greater than or equal to 4. Negative y is greater than or equal to negative x plus 4. Now I multiplied by a negative. So since I multiplied by a negative, what do you do when you multiply by a negative? You switch the symbol. So you gotta be a little bit careful with that. Okay, so it's greater than or equal to, so it's gonna be solid. Now it's greater than it, so we're gonna shade above. So there's my first one. Now I'm done with the first one. Now we have to do the second one. The second one says x is greater than or equal to negative 2. So we have to graph the line x is equal to 2. So remember, when you're doing x equals, those are vertical lines. So we do a vertical line at 2. We'll say it's right there. Nice and straight. Beautiful. So x is 2, but now it says x is greater than negative 2. So if it's greater than negative 2, I just did 2. Why did I do 2? Let's erase that. That should be negative 2. My error. Negative 2 is right there probably instead. Sorry about that. It says x is greater than negative 2, so it's all of this region over here. Now my solutions are only going to be the ones that are double shaded. So I'm not going to bother shading this stuff down here. There's no reason for me to shade that down there, because that's not going to be part of my solution. The only part of my solutions is the part that's been double shaded. So all of my solutions for this are right here. So you just do both of them when you're doing these. Okay, let's look and see how they did it. Okay, there's their first one. There's their second one. Put them together and you're good. Okay. So next one, we're going to graph the union of two linear inequalities. So again, we've kind of already done this. So we've got 7x minus 3y is less than 21, or x is greater than 2. Again, we can just go ahead and do this however we want to do it again. I'm going to leave it as an inequality this time. So I'm going to subtract 7x. Divide by negative 3. This should be plus 21. When I divide by -3, I have to switch the symbol. That's just going to be 7/3 x minus 7. So there's my first one. My y-intercept is -7. It's right there. My slope is right here. That's telling me to go up 7/3. I look at my symbol. It's now greater than. So I put a dashed line. And now I'm going to look at my sign here. Don't look up at the top. Look down there. It's greater than. So greater than means I shade above. There's the first one. Second one. X is greater than 2. So we graph the line at 2. Oops, sorry. Look at the symbol. See, it's an error that happens all the time. It's dashed. It says it's greater than 2. I'm only going to shade the region that's been shaded once already. There's your solution for those two. So again, it just becomes graphing both of them and finding out where you're kind of double shaded. And your assignment is going to have a graph thing for you, so it'll kind of help you determine it kind of on your homework assignment. Okay, so there's what they have. So when you're graphing systems of any linear inequalities with two variables, if you're just graphing it, one of them just graph away. Make sure you pay attention to if it's less than or equal to, greater than or equal to. If you need a solid line, or less than or greater than, you need a dashed line. Also make sure you're taking a peek at where do you shade. Do you shade above it, below it? Remember, if you put it in the form y equals mx plus b, if y is greater than, you shade above. If y is less than, you shade below. But that only works if you put it in kind of slope-intercept form. Otherwise, use a test point. If there are two of them, just graph them separately. Your solutions are where they are both and double shaded. So yeah, that takes care of section 3-4. We've got one section left to go in this chapter, and we should be done with this. Yeah, I'll go do that one here in like a couple minutes. So take care of yourselves. Talk to you next time.